Hi everyone, I am Jishi, Assistant Professor from the Department of Computer Science and Engineering, working in Emmanuel Arasar JG College of Engineering. So, in today's session, we'll be going to learn about principles of object-oriented programming. So, before entering to the introduction of object-oriented programming, first let us understand a basic idea. What is called programming? Programming is the process of giving instructions to a computer to perform tasks. In traditional programming, we mainly focus on functions and logic. But now, here comes a question: is traditional programming a best way to design large and complex software? The answer is no. Why? Because in traditional programming, the program is mainly organized around functions and step-by-step logic. While this works well for small programs, but it becomes difficult when the system grows large. So, in order to overcome these problems, object-oriented programming was introduced. Now, let's move to the concept of object-oriented programming. So, what is called object-oriented programming? Object-oriented programming is a programming paradigm that focuses on organizing software design around objects rather than functions and logic. Which means instead of writing long and complex code, object-oriented programming allows us to divide the program into smaller parts called objects. So, in object-oriented programming, real-world entities such as students, cars and bank accounts are represented as objects in a program. Each object contains both data and the methods that operate on that data. So, one of the biggest advantage of object-oriented programming is it allows us to represent real-world entities inside a program. For example, a student, a car, a bank account, all these are real-world objects. So, the next one is the main goal of object-oriented programming is to improve code reusability, scalability, and maintainability. Instead of writing long procedural code, object-oriented programming divides the program into smaller modules called objects, which interact with each other. This approach makes complex systems easier to understand and manage. So here it means using object-oriented programming, we can reuse the same code in multiple places. We can easily expand the program when needed, and it becomes easier to maintain and update the code without affecting the whole system. Instead of writing one big and complex problem, object-oriented programming breaks it into smaller parts called objects. Each object does a specific task and all the objects communicate with each other to complete the program. Even if the system is very large, it becomes easy to understand, debug and manage because everything is organized into smaller and simple parts. And the next one is object-oriented program is widely used in modern programming languages like C++, Java and Python, and it plays a crucial role in developing large-scale applications. Which means most of the popular programming language we use today such as C++, Java and Python are based on object-oriented programming concept. So object-oriented programming is very important when developing large and complex applications like banking systems, web applications and mobile apps because it helps in organizing the code in a better and more efficient way. So, in simple term, object-oriented programming makes it easier to build, manage and scale large software systems. So, the next one is characteristics of object-oriented languages. There are 8 characteristics in object-oriented languages. They are: objects, classes, encapsulation, data abstraction, inheritance, polymorphism, dynamic binding, and message passing. So the first one is objects. An object is a fundamental building block of object-oriented programming. It represents a real-world entity and contains both state and behavior. The state of an object refers to its data or attributes, while behavior refers to the operations or functions it can perform. Which means, in object-oriented programming, everything is created and organized using objects. So, objects form the base of the entire programming approach. An object is used to model real life things like a student, car, or bank account. It includes both the data and the actions related to it. The state represents the properties of the object such as name, age, or color, which describe its current condition. Behavior defines what actions the object can do, like studying, driving, or withdrawing money. So, in simple terms, an object is a combination of data and actions that can be performed on that data. So, the next point is, each object has a unique identity and occupies memory when it is created. Objects are instances of a class, meaning they are created based on the structure defined in the class. It means every object is different from others. Even if they have similar properties, memory is allocated to an object only when it is actually created during program execution. And a class acts like a blueprint or template, and objects are created from that blueprint. So every object follows the structure and properties defined in its class. So a class defines the structure and objects are the actual implementation of that structure. So consider an example. A student object may have attributes such as name, age, and marks, and behaviors such as studying and writing exams. By creating multiple objects, we can represent multiple real-world entities within a program. Which means, if we take a student as an object, its state or data will include properties like name, age, and marks. The student object can also perform actions like studying and writing exams, which represent its behavior. We can create many student objects, and each object can represent a different student with its own data, allowing us to model real-world scenarios inside the program. So, objects help us to represent real-world entities in a simple and organized way. So, the next one is classes. A class is a blueprint or template used to create objects. It defines the properties and behaviors that the objects created from it will have. Classes are considered using user-defined data types in object-oriented programming. Means a class acts like a model or design from which we can create multiple objects. Just like a blueprint is used to construct many buildings. The class specifies what data the object will store and what actions it can perform. So, every object created from that class will follow the same structure. A class is created by the programmer and it works like a new data type that can be used to create objects. So, the next point is, when a class is declared, it does not occupy memory. Memory is allocated only when objects of that class are created. A single class can be used to create multiple objects, each having its own data but sharing the same structure and behavior. It means simply defining a class will not use any memory because it is only a blueprint and not an actual entity. Memory is assigned only when we create objects from that class. Since objects are the actual instances that store data, we can create many objects using the same class. Every object will have its own separate values, but all of them follow the same properties and functions defined in the class. So, a class provides the structure and multiple objects can be created from it, each with its own data. And the next point is classes help in organizing code efficiently and promote modular programming. They act as a logical structure, whereas objects are the physical entities created from that structure, which means class allow us to structure the program into smaller manageable parts, making the code easier to read, understand and maintain. A class is just a design or plan, and objects are the actual instances created from that plan which occupy memory and perform actions. So, classes define the structure and objects are the real implementations of that structure. So, the next one is encapsulation. So, encapsulation is the process of combining data and methods into a single unit, typically within a class. It also involves restricting direct access to some of the object's components, which is known as data hiding. So, which is nothing but it means in object oriented programming, we group the data and the functions that operate on that data together inside one unit called a class. We do not allow direct access to certain data members. Instead, we control access using methods, which helps protect the data from unauthorized chances. So, encapsulation helps in combining data and functions together and also ensures data security through controlled access. So, the next point is in encapsulation, data members are usually declared as private and access to them is provided through public methods. This ensures that the internal representation of an object is hidden from the outside world and only controlled access is allowed. So, here it means the data inside a class is kept private, so it cannot be accessed directly from outside. Instead, we use public functions or methods to access or modify that data. The actual details of how the data is stored and managed are hidden, so external users cannot see or directly interact with it. We can control how the data is accessed or modified by defining specific methods, which improves security and prevents unwanted changes. So, encapsulation provides data hiding and controlled access, making the program more secure and reliable. The next point is encapsulation improves the security of the program by preventing unauthorized access and modification of data. It also enhances maintainability as changes to the internal implementation do not affect other parts of the program. It means since the data is hidden and cannot be accessed directly, only authorized methods can modify it, which protects the data from accidental or incorrect changes. We can modify the internal code of the class without impacting other parts of the program, because external code interacts only through public methods. So, encapsulation improves both security and maintainability by protecting data and allowing safe changes to the program. And the next one is data abstraction. Data abstraction is the concept of hiding the complex implementation details and showing only the essential features of an object. It focuses on what an object does rather than how it does it. Means we hide the internal working details of an object and only expose the important features that the user needs to see. We are concerned with the functionality of the object, not the internal logic behind it. So, abstraction simplifies the program by hiding complexity and showing only the necessary information to the user. And the next one is abstraction is achieved using abstract classes and interfaces. These allow the programmer to define only the necessary functionalities while leaving the implementation details to be defined later. So here in C++, Java or similar languages, we use abstract classes and interfaces to implement abstraction. We only specify what operations or methods should be available without writing the full implementation. The actual code for those methods can be written later in derived classes, giving flexibility in how the functionality is implemented. So abstraction allows us to define what needs to be done while hiding how it is done. The next one is the main advantage of abstraction is that it reduces complexity and makes the system easier to use and understand. It also enhances security by hiding sensitive implementation details from the user. So which is nothing but it means by hiding unnecessary details, the system becomes simpler and users can focus only on the important features without worrying about how everything works internally. Important internal logic is not exposed to the user, which helps protect the system from misuse or unauthorized access. So abstraction simplifies the system and improves security by hiding internal details. So, and the next one is inheritance. Inheritance is the mechanism in which one class acquires the properties and behaviors of another class. The class that inherits is called the child or derived class, and the class from which it inherits is called the parent or base class, which means one class can use the data and functions of another class. So we don't need to write the same code again. The class that receives the properties is known as the child class or derived class. The class that provides the properties and methods is called the parent class or base class. So inheritance helps in reusing existing code by creating a relationship between classes. So the next point is inheritance promotes code reusability by allowing the reuse of existing code instead of writing it again. It also helps in establishing a hierarchical relationship between classes. So it means we can use the properties and methods of an existing class in a new class. So we don't have to rewrite the same code again and again. Inheritance creates a parent-child relationship between classes, organizing them in a structured way like a hierarchy. So inheritance not only reduces code duplication but also helps in organizing classes in a clear hierarchical structure. So the next one is there are different types of inheritance including single, multiple, multi-level and hierarchical inheritance. By using inheritance, a program becomes more organized and easier to extend. So here inheritance can be implemented in different ways depending on how classes are related, such as one class inheriting from another class, multiple classes inheriting or forming levels, and hierarchical instance helps structure the program in a better way. And it becomes easier to add new features without changing existing code. So, inheritance provides different ways to reuse and organize code, making programs flexible and easy to expand. So, the next one is polymorphism. Polymorphism is the ability of a function or method to perform different tasks based on the context. The term polymorphism means many forms. It means the same function or method can behave differently depending on how it is used or the type of input it receives. A single function name can have multiple forms or implementations performing different operations in different situations. So, polymorphism allows one function to perform multiple tasks, making the program more flexible and efficient. And the next one is, in object oriented programming, polymorphism allows the same function name to be used for different operations. It can be achieved in two ways: compile time polymorphism and runtime polymorphism. Compile time polymorphism is achieved through function overloading, while runtime polymorphism is achieved through function overriding, which means we can use one function name but it can perform different tasks depending on the situation or input. Polymorphism can be implemented in two different forms based on when the function behavior is decided. We can define multiple functions with the same name but different parameters, and the compiler decides which function to call during compilation. A child class can redefine a function of the parent class, and the decision of which function to call is made during program execution. So, polymorphism allows one function name to perform multiple tasks using overloading and overriding. The next one is, polymorphism increases flexibility and makes the code more reusable and scalable. It allows programmers to write more generalized and efficient code. Here it means polymorphism allows us to use the same function in different ways, making the program more flexible. It also helps in reusing code and makes it easier to expand the program when needed. Instead of writing separate code for each case, we can write one common function that works in multiple situations, which improves efficiency and reduces code duplication. And the next one is dynamic binding. Dynamic binding refers to the process of linking a function call to its implementation at runtime instead of compile time. It is also known as late binding, which means the decision of which function to execute is not made when the program is compiled, but it is decided when the program is running. Since the function call is resolved at a later stage instead during execution, it is also called as late binding. And the next one is, this concept is mainly associated with runtime polymorphism and function overriding. When a base class reference is used to call a derived class function, the actual function to be executed is determined at runtime. So here it means dynamic binding is closely related to runtime polymorphism. Where a child class overrides a function of the parent class, we use a parent class reference to refer the child class object. The program decides which function to execute only during execution based on the actual object type, not the reference type. So, dynamic binding ensures that the correct function is called at runtime, providing flexibility in object-oriented programming. The third point is, dynamic binding provides flexibility and allows the program to decide which method to execute during its execution, making it more dynamic and adaptable. So, it means the program is not fixed to one method at compile time. Instead, it can choose the appropriate method while the program is running. The program can easily adjust to different situations and behaviors, making it more flexible and capable of handling changes. So, dynamic binding makes the program more flexible by deciding the method at runtime based on the situation. So, the next one is message passing. Message passing is the process by which objects communicate with each other by sending and receiving messages. A message is essentially a method call from one object to another. So it means in object-oriented programming, objects do not work in isolation. They interact with each other by exchanging messages. When one object wants another object to perform an action, it calls the method of that object, and this method call is called a message. So, message passing allows objects to communicate and work together to complete tasks in a program. And the next point is, when an object sends a message, it requests another object to execute a specific method. The receiving object processes the message and returns a response if necessary. It means one object asks another object to perform a particular action by calling one of its methods. The object that receives the request will execute the method and, if needed, send back a result or output. So objects communicate by sending requests and receiving responses through method calls. And message passing helps in achieving modularity and loose coupling between objects. It makes the system more flexible and easier to debug and maintain. It means object works as an independent unit and they interact only through messages. So they are not tightly dependent on each other. Since the program is divided into smaller independent parts, it becomes easier to identify errors, update the code and modify the system without affecting other parts. So message passing improves modularity and makes the system flexible, easy to debug and maintain. So the conclusion of the characteristics of object-oriented programming are as follows. So object-oriented programming provides a powerful way to structure and design software applications by using objects such as classes, objects, encapsulation, abstraction, inheritance, polymorphism, dynamic binding and message passing. Programmers can develop systems that are more efficient, secure and easy to maintain. So it means object-oriented programming helps us organize and develop programs in a more structured and effective way compared to traditional programming. All these object-oriented principles work together to improve how the program is designed and how different parts of the system interact. Using object-oriented programming, it makes the program faster, safer and easier to update or modify in the future. So, object-oriented programming plays a key role in building modern, reliable and scalable software system. So, and the next one is C++ program structure. So, C++ program structure contains 6 sections. They are document section, link section, definition section, global declaration section, main function and user defined function. The first section is document section. The document section consists of comments that describe the program, which means this section contains explanations written by the programmer to describe what the program does. So these comments are ignored by the compiler and are meant only for human understanding. So it means the compiler does not execute these comments, they are only for developers to read and understand the code better. So document section typically includes program title, author name, date of creation, description of the programming logic. So we include basic details about the program such as its name, who created it, when it was created and a brief explanation of how it works. So the next one is comments improve code readability and maintainability, especially in large programs or team projects. It means comments make the code easier to understand and they help other programmers to maintain and update the program easily. So there are 2 types of comments in C++. They are single line comment and multi-line comment. So consider this example. This program adds 2 integers. So which means this is a multi-line comment used for documentation. It gives the program title and a short description. So anyone reading the code can easily understand its purpose. And the next section is link section. The link section is used to include header files required for the program, which means this section is used to add the necessary libraries that provide predefined functions and features needed for the program. So, the syntax of link section is hash include header file. Common header files includes IO stream is used for input output operations, mathematical functions is used for calculating math, string is used to handling string functions. So this section helps in code reuse and simplifies programming. So consider this example. In this example, the line hash include IO stream is used to include the input output library, which allows us to use functions like cout. The statement using namespace std enables us to use standard functions without writing std scope resolution operator repeatedly. The line hash define pi 3.14 defines a constant named pi, which is used to represent So now consider this example. In this program, we include hash include IO stream. It allows us to use input and output functions like cout and cin. So the next section is definition section. The definition section is used to define constants, macros and symbolic names. It means in this section, we define fixed values and meaningful names that will be used throughout the program. So, it improves readability by replacing fixed values with meaningful names. So, it means instead of using numbers directly in the code, we use names, which makes the program easier to understand. Definition section consists of two common methods. They are hash define and const. Hash define is used for macros, which means it is used to define constant values or expressions before the program is compiled. And the next method is const, used for constant variables. It means const is used to declare variables whose values cannot be changed during the program execution. So this section helps, that is, the advantages of this definition sections are it avoids repetition. It means we don't have to write the same value again and again. The next one is it makes code easy to modify. It means we need to change a value, we can change it in one place instead of updating it everywhere. And the last one, reducing errors. Reducing errors is nothing but it means using fixed names instead of repeated values reduces the chance of mistakes. And consider this example. Now, in this example, the line hash include IO stream is used to include the input output library, which allows us to use functions like cout. The statement using namespace std enables us to use standard functions without writing std scope resolution operator repeatedly. The line hash define pi 3.15 defines a constant named pi, which is used to represent the value of pi throughout the program. It improves readability and avoiding repetition. Inside the main function, a variable radius is declared and initialized with the value 4. A comment is included to indicate that the next step is calculating the area of a circle. The statement cout pi into radius star radius computes the area using the formula pi r square and display the result. Finally, return 0 indicates the successful completion of the program. So the next section is global declaration section. Global declaration section includes variables and functions defined outside the main function. So, the global declaration section includes variables and function declarations that are defined outside the main function. This means these variables known as global variables can be accessed and used from any part of the program. It is used to declare function prototypes which specify the function before its actual definition and to define global constants that remain unchanged throughout the program. The main advantage of this section is that it allows easy sharing of data between different functions, reducing the need to pass parameters repeatedly. This makes the program simpler and more efficient, especially in larger applications. And now consider this example. In this example, hash include IO stream is used to include the input-output library, and using namespace std allows us to use standard functions like cout without scope resolution operator prefix. The variable int x is equal to 10 is declared outside the main function, making it a global variable that can be accessed from any part of the program. The line void display is a function prototype which declares the function before it is used. Inside the main function, the display function is called. The actual definition of the display function is written after main function. And inside this function, the global variable x is accessed and printed using cout. This example shows how global variables can be shared across functions without passing them as parameters. And the next section is main function. The main function is the entry point of the C++ program, which means the execution of any C++ program always begins from this function. No matter how many functions are defined in the program, the control first enters the main function and starts executing the statements written inside that. So, the basic structure of the main function is int main and statement return 0 and so on, where all the important instructions of the program are written within the braces. It contains the main logic of the program such as variable declarations, function calls and operations that need to be performed. Every C++ program must have a main function because without it, the compiler will not know where to start execution and the program will not run. The statement return 0 is used to indicate that the program has executed successfully. Now, consider this example. In this example, hash include IO stream is used to include the input-output library, which allows us to use cout for displaying output. And using namespace std helps us to use standard functions without the std scope resolution operator prefix. The main function is the starting point of the program where execution begins. Inside the main function, two integer variables or a and b are declared and initialized with the values 5 and 3. A comment is included to indicate that the next step is performing addition. The statement cout a plus b calculates the sum of the two variables and displays the result on the screen. Finally, return 0 indicates that the program has executed successfully and terminates properly. This example demonstrates how the main function contains the core logic of the program and controls its execution. So, the next section is user-defined function. User-defined functions are functions created by the programmer to perform specific tasks. So, they help in code reusability, reducing complexity and improving modularity. So, these functions help in code reusability as the same function can be used multiple times without writing the code and they also reduce complexity by breaking the large problem into simpler subparts. So this improves modularity where each function handles a specific operation independently. A user-defined function generally includes three main parts: the function declaration or prototype, which tells the compiler about the function definition where the actual code is written, and the function call, which is used to execute the function. The advantages of using user-defined functions include avoiding repetition of code, making the program more structured and organized, and making it easier to debug and maintain, especially in large programs. So now consider this example. In this program, hash include IO string is used to include the input output library, and using namespace std allows us to use standard functions like cout. The line int add of int a comma int b is the function declaration prototype, which informs the compiler about the function before it is used. Inside the main function, a variable result is declared to store the output. The function is then called using result equal to add of 5, 3 function, where the values 5 and 3 are passed as arguments to the function. The returned value is stored in the variable result and displayed using cout. After that, return 0 indicates successful execution of the program. The actual function definition is written after the main function, where the function add takes two parameters and returns their sum. And the next topic is tokens. Tokens are nothing but it is the smallest individual units in the program. There are 5 tokens in C++ programming. They are keywords, identifiers, constants, strings, and operators. The first one is keywords. Keywords are reserved words in C++ that have predefined meanings and cannot be used as identifiers such as variable names or function names. These words are already predefined by the compiler to perform specific operations, so their meaning cannot be changed. For example, in the statement int num is equal to 10, the word int is a keyword used to define an integer data type. Similarly, in the condition if num greater than 5, the word if is a keyword used for decision making. This example shows how keywords are used in a program to define structure and logic, and why they cannot be used as names for variables or functions. And the next one is identifiers. Identifiers are the names given to variables, functions, arrays, and other elements in a program, and they are used to uniquely identify these elements. In simple terms, identifiers helps us refer to different parts of a program by giving them meaningful names. For example, in the statement int age is equal to 20, the name age is an identifier used for a variable. Similarly, in the function void display, the name display is an identifier used for a function. So this example shows how identifiers are used to name and access different components of a program, making the code more understandable and organized. And the next one is constants. Constants are fixed values in a program that do not change during execution. Once a value is assigned to a constant, it cannot be modified, which helps in maintaining consistency and preventing accidental changes in the program. Constants are used when we want certain values to remain the same throughout the program. For example, in the statement const int x is equal to 10, the variable x is declared as a constant, so its value cannot be changed later. Similarly, hash defined pi 3.14 is a macro constant where the value of pi is defined and used throughout the program. This makes the code more readable and easier to maintain by avoiding repeated use of fixed values. And the next one is string. A string is a sequence of characters enclosed in double quotes, and it is used to store text data in a program. Strings are commonly used to represent names, messages, and other textual information. In this example, hash include IO string is used to include the input-output library, and using namespace std allows us to use standard functions like cout. Inside the main function, a string variable name is declared and initialized with the value priya. The statement cout name is used to display the value of the string on the screen. Finally, return 0 indicates the successful execution of the program. This example shows how strings are used to store, display text data in C++. And the last one is operators. Operators are symbols used to perform operations on variables and values in a program. They are essential for carrying out calculations, comparisons, and logical decisions. There are different types of operators in C++, such as arithmetic operators like plus, minus, and so on are used for mathematical operations, and relational operators like greater than, less than, equal to used to compare values, and logical operators like AND are used to combine conditions. In this example, two variables a and b are declared and initialized with values 10 and 5. The statement cout a plus b uses the arithmetic operator plus to add the two values and display the result. Similarly, cout a greater than b uses the relational operator greater than symbol to compare the values of a and b